Hello everyone and welcome back to Fun Mathology. Today's topic is prime factorization. Now, in the last class, I have discussed that today we'll be discussing prime factorization after we have seen how to find out the factors of a given number. Now, what is a prime factorization method? So, this is the process of writing a natural number as the product of prime factors, and this is called prime factorization method. Okay, so there are two methods actually to find out the prime factorization of a number. So all the factors that we are going to extract of a number will be prime numbers, right? So there are two methods. So today in this lecture we'll see the first method, that is known as factor tree method. Got it? So there are more ways to find out a factor tree. So if you get a number and try to solve this prime factorization by factor tree method, so there is no single way of finding out. Let's say I am following a particular process, you can follow another process. I'll show you why and how. Okay, so prime factorization of any natural number can be represented as a factor tree. Now what is a tree? So we'll see an inverted tree will form an inverted tree of a particular number. So solving the prime factorization of any number, so we can create a factor tree. So let's take a number like 18. Got it? So we'll circle it. So this will be the starting of the tree, right? So we'll draw two arrows here. Two arrows will move into two directions. So in the first arrow, so we'll take the first prime number, that is after 1, that is 2. So 1 is not a prime number, not a composite number. So the first prime number is 2. So we'll see that if 18 is divisible by 2, so yes, this is 9. So this ends here. Now we can see 9 is not divisible by 2, but 9 is divisible by the next prime number, that is 3. So we'll make two branches here again. So the first branch will lead to 3. So 9 divided by 3 is 3. Got it? So for the last 3, we'll just make two branches. Again, we'll write 3 and 1. Got it? So see, so we can write prime factors of 18 is 2 multiplied by 3 multiplied by 3, right? So 2 multiplied by 3 multiplied by 3. So 3 to the 6, 3 is 18, right? So this is the factor tree method. Now why I have said that there is no single way to find out this factor tree? As I am following one process, you might follow another process. Let's say somebody might start 9, 18 divisible by 9. So they can start on the left hand side by 9. Got it? And form the factor tree on the left hand side, and that is also possible. But I'll recommend to follow this particular step, which is much more easy. Let's see another example, and this will make the method more clear to you. So we'll take 112 as the number. So we'll start with making two branches. So one circle here, one circle here. So we'll start with 2. So 112 divided by 2 is 56. So again from 56 we'll create two branches. So again 56 is divisible by 2. So we'll not stop dividing the numbers as we get in the sequential or in the subsequent steps by dividing the same prime number until and unless we'll see that it is not divisible by the same prime number. So we'll continue with 2. Got it? So 28. So we'll again see it is also divisible by 2. So we'll keep on dividing the numbers by 2. So this is 14. So obviously again this is divisible by 2. So we'll stick to 2. The answer is 7. So from here we'll take 2 branches, 7 and 1. See, we'll take this one. So this are the prime factors of 112. So we'll write here prime factors of 112 will be 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 7. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 into 7 is 112. Got it? So this is the first method, is a factor tree method, which is very easy. This is the method to find out the prime factorization of a number or the prime factors of a number. Got it? I think you have understood the lecture. Okay, in the next lecture we'll see the second method to find out the prime factorization of a number. So students, thank you so much for watching. If you have any questions, you can let me know and I'll try to answer those questions as soon as possible. Well, thanks for watching. Have a great day. Bye bye for now.